Okay, good morning everybody. My name is Richard Nolan and welcome to this morning's session. We're going to be using GoToMeeting technology. So on the sidebar, if you want to ask a question, if you just type it in there and we will get back to you. So okay, so basically if we can just move on to the intro slide there. As I said, my name is Richard Nolan. I head up the digital sales team in Kodak. We're very focused on delivering value through our various practices. And this morning, we're going to be presented to by Owen Barry, who heads up our DevOps practice in the company. So this is a really exciting area for us. It's actually the biggest, the fastest growing part of our business, and we generally deal with a lot of ISVs, software development departments, and so on. Owen did work, and he set up the DevOps practice within Ryanair, and was there for about 4 or 5 years, and is building the team in Kodak over the last 2 years. So before we kick off with the main presentation, I just want to take you through basically 2 slides here and give you a quick look at Kodak and where we are today. So we've been around for 30 years. We've got offices all over Ireland, UK, Germany and Poland. Our revenues are around 30 million, and we are looking to hit about 40 million in this financial year, which we've got pretty good visibility on. Our headcount has risen very rapidly over the last number of years to 242. And to put that in context, we had about 100 staff 2.5 years ago. But we stopped doing a whole bunch of things and really focused on basically cloud technology, and that's around Microsoft, which is 90% of our business. And then we also have a smaller Hyperion practice, which is about 10% of our business. Last year in 2018, we won the 3 major awards from Microsoft, which was the Country Partner of the Year, the Digital Transformation Partner of the Year, and BizApps Partner of the Year. So we're obviously doing things that Microsoft think are very good for a partner to do. And as it turns out, we are the only full stack partner in our end. So over the 30 odd years, we have worked with many companies across different sectors. So we have accumulated a lot of knowledge about these organizations and projects, and it goes very much along with our value proposition. So one of the main things that we like to do is that we, as a full stack partner, not only do we have various practices that can deliver across the board here, we also do the provisioning of the software as well. So for example, if you're looking for Azure or Office 365 or Microsoft 365 or so on, we are what's called a CSP direct partner of Microsoft. So we provision the tenancies and subscriptions directly from the data center to the customer, so avoiding the costs of going through distribution and wholesalers and all that kind of stuff. So that works out quite well from a cost point of view. So basically, I'd like to hand over now to Owen. And Owen, would you like to take on the controls?
No problem. Thanks very much, Richard. So as Richard said, my name is Owen Barry. I'm the head of software development and DevOps here in Kodak. So today we're going to talk about DevOps and how to eliminate waste and reduce time to market. So what I'd like to do for this talk is kind of take a lot of people have kind of preconceived notions of what DevOps are. A lot of companies are implementing it and aren't necessarily making the most of the potential of what DevOps can provide. So we're going to take a look at this kind of from a business perspective today. We won't get into the weeds with the technology. We'll take a step back and look at it from a business perspective and see how we can use DevOps methodologies and techniques to improve your time to market and introduce efficiencies. So we'll start with looking at, I suppose, why companies are looking at DevOps, why companies make the move to DevOps. And then we'll take a step back and we'll ask the question, what is DevOps? So a lot of people kind of misunderstand it and invest heavily in it. but don't really have a fundamental understanding of what it actually is. So take a step back and examine that. After this, we'll have a look at a high-performing team, a real-life example of one of our teams that are within the elite category of DevOps performance and what that looks like. We'll look at why companies that take on DevOps transformations fail, one of the major reasons they fail. And from there, we'll start looking at how you take steps to understand your value stream within your software delivery capability. From that, then we'll look at optimizing your value stream in order to improve flow. We'll look at how you scale delivery then once you've made those efficiencies within your value stream. And then we'll look at specifically microservices, how microservices, continuous delivery, and all those technical practices that we hear about when we talk about DevOps, how they fit into the picture. And you'll notice that this is pretty much at the end of the discussion. So we're going to talk about all the things that you need to do in order to enable your organization to adopt DevOps effectively. And finally, we're going to look at some specific practices, some specific best practices, things like continuous delivery, which help improve flow and how to implement them. So I'm hoping to get through this in about 45 minutes. So if there's any questions, just ping them here on the system. I'll try and get around to them, and if we don't fit them all in, I'll get back by email if possible. Okay, so we'll start by why DevOps. Why are companies across the world adopting DevOps? Well, a lot of it is down to kind of the results people are getting from adopting these DevOps practices. So the State of DevOps report from DORA is a survey that goes out to 20 to 30,000 IT specialists across the world yearly. This year came back saying that elite performers, as opposed to low-performing companies, have 208 times more frequent code deployments, 106 times faster lead time from commit to deploy, 2,604 times faster time to recover from incidents, and 7 times lower change failure rate. So the benefits in doing this right are fairly significant in terms of efficiencies within your organization. So that's part of it, and the other part of it is people just hear that this is a good practice and kind of say, okay, everybody's doing it, so we need to do DevOps. So these benefits can kind of be broadly categorized by throughput, more frequent code releases or reduced lead time, and stability, which is improved stability and faster recovery from incidents. So if you kind of take a step back and look at what that means, it means that elite performers, performing teams experience less waste than poor performers. So that's kind of the theme of today. We're going to have a look at how you deliver your software, how to identify waste, how to remove it, and enable this this high performance in your DevOps capability. So to take a step back before we kind of jump into it, just to make sure that everybody's on the same page, we'll look at the dictionary definition of what DevOps is. So DevOps is a cross-disciplinary community of practice dedicated to the study of building, evolving, and operating rapidly changing resilient systems at scale, right? So it's a kind of a mouthful, but what does it mean? You'll notice there's nothing about Kubernetes or microservices or anything like that in there. It's a community of practice, cross-disciplinary community of practice, which is dedicated to building, evolving, operating systems that change rapidly and with built-in resilience at scale. So it's best practices to enable you to do this. The disciplines involved are agile product management specifically. So if you're a team that, or an IT department that works with project managers, works in a waterfall way, this is kind of, it doesn't work with DevOps. DevOps is specifically about agile product management, lean product management. Security, best practices, architecture, lean software development, QA, repository management, operations, configuration management, release management. So if you look at this list of disciplines and you think of kind of what DevOps has kind of come to mean in the community. When you think of DevOps, everyone kind of jumps towards release management. They think about, you know, continuous integration, continuous delivery, Kubernetes. This is basically release management and a little bit of operations. There's so much more that in the picture that's incredibly important in order to achieve that elite performance within your team. So how did DevOps come about? So traditionally, back in the day, well, not back in the day, a lot of companies are still working in this waterfall way, where your project management and BA team will go out, have a look at requirements from customers, create projects, put a bunch of features within that project, do requirements analysis, design up front, a big implementation phase, which is generally siloed between multiple specialty teams, so front end, back end, Android, iOS, integrations, architecture, for example. You'll have a big test phase and a big release phase at the end of that. The problem with this is that the lead times are very long in this case, in this kind of setup. In some cases, it takes a number of years to get an iteration of a product out to your customer base. As well as that, you're not taking customer feedback as you design it. So very often what you deliver isn't actually what the customer needs. So the agile world tried to fix this. So back in '99, Scrum and XP kind of came to the fore. So Scrum won out. So when people talk about agile now, you kind of automatically jump to Scrum. How Scrum works is you get a smaller batch of features. You have a small inception phase, small analysis phase, and then in small iterations, you do plan, develop, and test over, say, 2-week sprints. The problem here is that there's no kind of provision for releases. At the end of the 2-week sprint, you don't necessarily have to release your code. So these sprints can roll on until the point when you get to a release to your customer. You're getting feedback as well. So you're getting feedback as you go on, but it's through the prism of a product owner. So the product owner is kind of standing as a proxy in a lot of cases to your customer. So they're making assumptions on customer behavior over all of these iterations. And by the time you go to release, very often what you're releasing is not what the customer wants. And again, there's a significant amount of waste in there and lead time. So some people who adopt Scrum have difficulty in getting their the development teams to be cross-functional. So one of the core kind of tenets of Agile is that you have cross-functional, self-organizing, fully autonomous teams responsible for parts of the application. But it's very difficult in some cases to do that with legacy teams there. So what you have then is you front end, back end, the same kind of functional silos working within their own scrums in parallel, which adds to the complexity, adds to lead times, and adds to the waste in the overall process. So another thing that's quite common is companies will go from this waterfall approach. They'll adapt Agile. They'll start doing scrums, doing all the ceremonies, standing up in the morning. They're 2-week sprints, 2-week iterations. But it's all wrapped up within this old waterfall approach. So they still have a project management team designing the projects. They're still doing upfront analysis, upfront estimation, big design documents, and then they're just delivering basically in the same way, only every 2 weeks they do a sprint. So in this case, you kind of got the worst of both worlds. So lead times kind of blow out as well. It's just a lot of complexity, a lot of unnecessary kind of waste within the process, and the lead times are still quite long. So why are long lead times, such a problem? So lead time being the time from when a customer requests a feature until that feature goes into production. Why is this a problem? Well, about 10 years ago, a guy from Microsoft called Ron Kohavi ran a set of experiments based on the features that they delivered from Microsoft, with the expectation that about 50% of what they did would actually add value. What he found is that actually 2/3 of what they were delivering added no value to the customer. There was actually no value in 2/3 of the software they were delivering because of this, their approach to software delivery. So this kind of sent ripples around the development community. So companies like Netflix and Amazon tried to validate these claims. So Netflix came back saying that actually 90% of what they were doing was adding no value. So they found that 90% of the features that they were adding that went to production actually added no or negative value. And Amazon had similar results. As well as that, there's there's a phenomenon that happens within most or every software delivery practice. Every project will have, or every backlog of features to deliver will have a small set of features that will carry 95% of the value of the entire backlog. So this is the power law curve from Maersk. So this is consistent across pretty much every company worldwide. You can see here that in Maersk, they have 5 or 6 features that carry pretty much all of the value of everything that's in the backlog. So for every week that they don't deliver these features, there's a cost of delaying that. So that cost of delay might be missed additional revenue from having that feature available, or it might be missed efficiencies that they can put into their delivery process that would save money. So this is typical of all backlogs. So if you're working in that project-based approach with huge lead times, you're wasting money. You're probably not prioritizing the most valuable features and doing them in a timely manner. Okay, so how do we get around this? So this is what DevOps with lean software development looks like. So this is how our teams here in Codec work. So we'll have a backlog of features. The features will be very light analysis. So they'll be pretty much one-liners as requests from a customer. We'll do stack order prioritization on them based on the value, the perceived value that will be brought back from the customer. So that could be cost of delay or expectation and additional revenue. For that feature, when the development team becomes available, the delivery team becomes available to take that feature, they'll pull it. And they'll do just-in-time analysis. They'll huddle around in a room for a day or 2 days if it takes it, and they'll plan how they're going to deliver this, what it looks like, the UX, security concerns, how they'll deliver it, how they'll release it, what the technical implementation will look like. And from there, they'll start to develop, test, and deploy in small iterations multiple times a day. So up to 20, 30 code deployments into production daily. And then at a point when we meet MVP for the feature, so minimum viable product, so the minimum functional requirements within that feature to make it viable to the customer, when that point is hit, we'll release it. So the guys here, they'll decouple deployments from release. So when they deploy their code to production, they'll use feature flags or feature toggles to switch that code on when it's available. So this means that we can deploy very, very small change sets to production multiple times a day. This takes the risk out of your releases. Your releases are pretty much risk-free. They do their tests. They automate all their tests. So they do automate acceptance test-driven development, test-driven development. So it means that for every commit, they can run this suite of acceptance tests and make sure that the system is good. And then once all these tests pass, automatically deploy into production. So full continuous deployment. So once they get that release, what we can do is experiment with a subset of the user. So we can do A/B experiments, A/B testing, where we can release this to a subset of customers and see how they're actually interacting with that feature and if it's actually adding value. So this initial MVP in some cases for features could be 1 or 2 days, as short as 1 or 2 days. And then we can run an experiment to see if there's any value in developing this any further. If there's value, then we continue to develop until the point where we do a final release, and then the guys will pull the next feature and plan again. So in this case, the lead time, as I said, is very, very low. Could be hours or a couple of days in some cases. And we remove a lot of waste around the the ceremony of getting the features out of production. So back to the slide. So once you can get to this point, this is what elite performance kind of looks like. You've got those frequent code deployments, faster lead time from commit to deploy, faster time to recover from incidents. So you have these small commits. If something goes wrong when you commit, you can just revert it very, very quickly. And you also have full automated test coverage. So you should capture much more of the incidents locally before it goes to production. And on top of that, you can do we have things like proactive monitoring that we can put into our systems, which will alert us before things go wrong or immediately when things go wrong in production and act on it. Okay, so this is again, this is specifically how the how you fall into the elite category. So deployment frequency will be on demand. Lead time for change is less than a day. Time to restore service less than 1 hour, or change failure rate is 0 to 15%. So this is one of our teams here in Codec. This is just a dashboard. I took the wrong snapshot of the dashboard. This is one of the dashboards there. You can see on the top right-hand corner, their cycle time is about 3 days. So this means from the time that they actually start developing a feature until it goes to production takes on average 3 days. Lead time is 15 days. So this is the point from when our customer requests a feature until that goes to production. It's 15 days on average. If we look at the cumulative flow here, it's quite interesting. One of the predictors of a low cycle time is a limit of work in progress. So these guys are working on one feature at any one time. The whole team swarms on it. So you can see here that there's only one feature in progress at any one time. And they'll follow that through until it's running in production. So working in this way, it removes all of the complexity around merging releases. We've got, as I said, full continuous deployment, and it means that they can move really, really quickly. Okay, so I'm going to talk through an example of a multinational here in Ireland that I was working with last year. Sorry. This multinational has 600 employees, 150 developers, and they had a lot of problems around delivering software, particularly around lead times. They wanted to get on top of their lead times. So they went out to a third party to come in and do a DevOps transformation for them. So they got the whole presentation around, this is what DevOps can do for you. This is the improvements of lead time you should expect, and throughput and stability and so on. And what happened was this incumbent came in, set up a centralized DevOps team who basically just built Jenkins scripts, CI/CD pipelines, put Kubernetes in place, and that was it basically. So if you look at we'll look at the process of how a feature came from the customer, or feature request came from the customer, and actually goes through to production within that IT department. So the customer will make a request. The request will come into a project management team. So they were working in the water scrum fall kind of way. So they had project management, doing upfront analysis, and then they go into a kind of scrum implementation phase. So they do their design and analysis. Following this, they did big upfront estimation and project approval. So they did costing and budgeting based on this estimation, and then they got project approval. And then they went into kind of Scrum release planning. So you can see there's kind of a huge conflict here. They're designing everything up front, they're estimating it, they're getting approval for this, so it's been rubber stamped. So now everything that they're saying they're going to be done is set in stone. So this is no longer agile. But then they move into an agile process where they do release planning, sprint planning, front-end development. They worked in feature branches, so every one of the developers would pick up a separate feature, separate story. That story will go into a feature branch. 600 developers, so you can imagine merges were hell. So they'd attempt to merge. Once the merges were done, there'd be releases, SAT, bugs would come in, go back to front-end development, another merge cycle, more releases, so on. UAT again, out to OAT, and into production. Bugs coming back all the time, more branches, more merges. Then they had back-end development team going through the same process. Second back-end development team, so they split their API into two. They had an integrations team. And as you can see here, the process was quite complicated, from getting customer requests all the way through to production. So as I said, they introduced a DevOps team, 3 DevOps engineers, 1 DevOps architect. They had a CAD board, so these guys took a seat on the CAD board. So every change that was made across the entire organization was subject to their approval with some other people, which is a huge bottleneck. CI/CD pipelines were introduced. So I put these into quotes because they weren't really CI or CD. If you're not integrating your commit to mainline multiple times a day, you're not doing continuous integration. If you're working in a kind of waterfall way, and you're not continuously delivering business value, you're not doing the CD side of this either. So it was just basically just release management. It's like traditional configuration management within waterfall. And all build configurations were developed centrally by the DevOps team, so it became another big bottleneck within the process. So despite adding a bottleneck in the process, the only thing after their year of work there that changed within this whole path to production was the releases became a bit faster, right? So releases, they were faster, they were automated. Pretty much nothing else changed. We still had that really heavyweight process of getting requests into delivery and through to production. So they probably spent in the region of 1 to 2 million, I think, on this transformation, but it was really a failure. It didn't do much. So the big thing that they did wrong here, their first big problem was they didn't understand their value stream. So that thing that we saw there, that's known as the value stream. This is every step that a piece of information takes from going from the customer through to production. So in this case, it's going through your project management team, through all the silos within your development team and out to production. So this essentially is your value stream. So when you're going on to if you want to improve your flow between your IT departments, if you want to get code out to production quickly, features out to production quickly, this is the first step. You really need to understand your value stream. So there's a process we can do called the value stream map, and we're going to look at that now in a minute. But before we look at it, I think it's important to look at what waste is. So if you remember at the start of the presentation when we introduced why people move to DevOps, we were looking at the reasons, and we identified that the reason that elite performance performs so well is that they've removed the waste from their delivery process. So what do we mean when we say waste? So from Mary and Tom Poppendike's book, Lean Software Development, they identified the seven types of waste within software development. These are partially done work, extra features, or overproduction. So these could be features that are designed by your upfront analysis that weren't needed by the customer, or even the analysis on features for the end customer that were never delivered. So this is overproduction. This is the worst kind of waste. Relearning, so this is where you solve a problem. It's not communicated or it's not encapsulated, and people need to solve that problem again. Handoffs, so having multiple functional silos within your IT department, all the handoffs between them, that's waste. Delays between those departments. Context switching, so things like changes in priority, or bugs or unplanned work that come up, and defects as well. So these are the seven types of waste that occur within your delivery process. So this is what a value stream map would look like for that for that delivery team. So I've simplified this a bit. I've taken the project management section out of this. So let's just make the assumption that the first thing that they need to do and their first thing that they should do if they're actually adopting the agile process is properly adopt the agile process. So anybody within that project management team should be repurposed as either product owners or scrum masters. That way they can fit within this scrum process properly, and it'll remove a huge amount of waste. The second thing is, second most important thing there is they'll no longer be working on a project basis. So if this was an online retailer, this online retail platform is a product. Working in projects, essentially, it's just wasteful. A project has a start and an end. And between the start and end of projects, you have downtime for your developers. So looking at it from a product perspective is better. So you always need new features on your product while the product is live. So if we can take out that project management piece at the start and work within the Scrum methodology, then that'll remove a huge bottleneck at the start. So on the right-hand side here, we can see this little icon here. This is the customer. The arrow here shows that a request from a customer will go to a backlog. It'll actually go to the backlog and through the prism of the product owner. And from here, they'll do sprint planning on the release and sprint planning on the backlog. So within this box here, we can see there's a cycle time and an operational time. So cycle time or process time means the amount of time it takes for that operation to start and finish. Operation time means the actual active time that it takes to do it. So for example, in sprint planning, for example, within development on a feature, you might start development on a feature, spend a day on it, and then something happens, you need to get more information, so you park that for a few days and then you complete it. So the cycle time is from when that started until it's actually completed. The operational time is the actual active time that it takes to deliver that. So each of these boxes here, they represent silos within the delivery process, or silos within the delivery process. So we can see there's sprint planning here, front-end development, back-end integrations team in 2-week sprints, so the cycle time there is 10 days. We've got a merge, so they spent a lot of time on merges. So we calculated it was about 25% of their development time was actually merge time. So it's fairly huge number. Release QA, release to UAT, release to OET, and then release to production. So you can see that the rolling count for cycle time for taking a feature from the backlog into production was approximately 41 working days, so about 8. Sorry, one second. So when you're looking at your value stream, it's important to note what your run rate is. So these guys had 125 developers. If we do a finger in the air of average salary of 50K per annum, there's a run rate of about 17,000 per day. So you get an idea of how expensive this kind of thing can be. So for every iteration of features into through the production, if there's waste in there, if you can drop that waste is an ongoing cost of 17 grand per day. And as well as that, it's kind of important to note the cost of delay. So for every for the time it takes to deliver your feature, there's lost opportunity cost there. So when those features go to production, the earlier you get it there, the earlier you can start generating revenue. So once you identify your value stream map, so this is a very easy process for anyone to do. So there's a couple of ways of doing it. One way, you can get a big sheet of paper, roll it out on the wall, get some stickies, and get people from the different departments to come into the room and mark off their own step within the process, and give you a rough estimation of how much time it takes. Another way of doing it is just getting a pen and a pad and walking around your IT department and walking up to people within these departments and figuring out, how does the information flow and how long does it take within these. So this is actually a bit of a simplified diagram or simplified map just for the sake of this, but the idea is the same. So the first thing to do once you've created your value stream map is identify bottlenecks. So let's look through your process and see if there's anything that jumps out that's wasteful. And based on that, you can make projections on how to improve this. You can suggest an alternative to the existing process and figure out how much this is going to save the business over a period of time. So looking at this, I suppose the first one that jumps out is these silos between the teams. So these functional silos are kind of a bad idea. So if we can remove these, we can really simplify the process. So that's the first one. Next one, I guess, is QA. Having QA in another silo in its own within its own team, away from the development team, is pretty wasteful as well. So that whole latency between raising bugs, getting the bugs handed back to the delivery team to deliver, that whole cycle is very wasteful. If you can build that into your development cycle, it's much more efficient. So that's another area. UAT is another one. So we can see that there's 20 days of UAT. So when features went out to UAT, it's often very hard to get the stakeholders involved, the relevant stakeholders involved, and to go through the big feature list and say that they're what they want. And again, if they make changes or say they don't like it, that whole cycle of redeveloping this is hugely painful as well. So this is another big area of waste. So what we could propose there is if we collapse this down to one development team. So if we take those functional silos and create cross-functional development teams delivery teams out of that. So with the capability of delivering software out to production, we'll remove a lot of the waste from merges. So you can see that we've removed this merge box as well. So if we can reduce the development teams to have one area of responsibility within the product, we can limit down the work in progress to one. So if these guys are working on one feature together, if you can get them to work on, you have a small development team, get them to work on one feature, take that feature and break it into subtasks, and get them to work on that until it goes to production. You no longer incur that huge cost of merging feature branches. The feature branch becomes kind of redundant. Basically, the guys are working on the one feature together. When it's complete, they can push this through to production. The other thing, as we mentioned, is merging dev with QA. So if we can do that, we'll remove 5 days of the cycle time. So notice how this is reducing as we move through. The next thing then, as we said, is UAT. If we do, we can do UAT in production if the new features are marked with feature flags. So if we adopt trunk-based development as a process, the guys who are delivering the software can mark each of these new parts of the code that they release with what's called a feature flag, and they can make that feature available to a subset of users. So one user group you can identify as your UAT users, and when that code goes out to production, you can make it available to them. So you're no longer holding production-ready code in this UAT silo and backing up all of this code that needs to be merged later on. You no longer need to do that. You can just deploy it out to production, make it available to the UAT team. When they're happy with it, they sign it off, and you can roll this out gradually to the customer base, to the user base. After this, then OAT, we can try and automate away as much of OAT as possible. So load performance testing, we can put in infosec checks, static code analysis, and so on. So much, if not all of this, these days can be automated away. Things like modern proactive monitoring tools as well means that pretty much all of this can go away. So when you come to this stage, then if you manage to do this, and you know this will take time, but it's a huge cultural change. It's a big change across all your teams. But if you manage to do this, and you come to a place where you've got sprints, you're working in 2-week iterations. The guys are working on one feature at a time. It probably no longer makes sense to work in sprints. I mean, what's to stop the guys releasing that feature once it's ready? Why would you work in 2-week iterations of delivering 4 or 5 things where you finish the first thing in a day? Why not just put it into production? So you can remove all that ceremony around sprint planning, all the kind of Scrum ceremony from there, and move into a continuous deployment kind of world where customer requirements go into a backlog. You take those requirements, you work on them, and you put them into production, nice and lean. So you could have cycle time down to 2 days, as is with our team there in the previous slide. So looking at it from this perspective, you can see there's a lot of waste in there, but this isn't enough. Just deleting boxes on a screen like that. It's if you have 600 developers, what do you do with the 600 developers? You can't put 600 developers on one team. It's not going to work. So there's another perspective you need to look at from this. We need to look at the organizational perspective. How do we organize those 600 developers or 150 developers? What responsibilities do they take? What architectural impacts does that have? How do we architect our system? And how do we deliver that out to production? So we'll have a look at that in a minute now. So I put a few links on here for anyone who's interested in looking into this a little bit deeper. So there's a great cheat sheet here from a company called Industrial Logic. They have a process called Modern Agile, and there's one around accelerating flow and the idea of MVP and evolutionary design of a product. There's a great little test here to test your maturity, your DevOps maturity on Google. And at the bottom there, it shows all the technical processes you need to improve your software delivery. So it touches on a lot of what we talked about there: cross-functional teams, value stream mapping, trunk-based development over feature branches, all of these technical processes that will really improve your software development delivery. So those links will be there, and I can share this with anyone who's interested afterwards. Okay, so we've looked at removing waste now from your value stream. We'll have a look now at scaling the delivery. So it's not enough, as I said, to just get everybody working on one team. So we need to have a look at how we scale this, how we silo people within the development teams. So we'll start with Conways Law. Conways Law is a architectural principle from a guy called Melvin Conway. It says that organizations are constrained to produce application designs which are copies of their communication structures. Back in the 60s or 70s, there's a guy called Melvin Conway. He's working on a set of compilers. He had 2 compilers that he wanted to build. He ran an experiment where he got 2 different groups to build the 2 compilers. One group consisted of 2 people. The other group consisted of 5 people. The solutions he got back, the one comprised of 2 people was a 2-part compiler. The compilation was done in 2 parts, and the team comprised of 5 people was a 5-part compiler. So the compiler was comprised of 5 parts. So what he deduced from this is, however you set up your organization to deliver your software, your application design will automatically mirror that. So the first step in architecting your system is making sure that you've organized your teams in a good way so the architecture will be correct. So what that means is, if you think back to the earlier slides where we saw the functional isolation within the team, so you have front-end teams, back-end teams, integration teams. These are all based on some technical responsibility. Good practice or best practice in the agile world is that you orient these teams to some market forces. So in this example here, this is a retail example. So in the retail company, you'll have different departments customer service, shipping, returns, sales, billing, human resources. Within these departments, you'll have different stakeholders or different heads of department. These people will be responsible for that part of the application. If we create cross-functional teams, delivery teams that are aligned to these departments, then what we can do is have these will act as like sub-products within the overall product. So you'll have a big overall ecosystem, and you'll have subcontexts within this. So within there, we can see that there are different types of processes, I guess, that go on. So for example, sales will have customers, orders, payments. Billing will have shippers, orders, payments. So if you look at something like orders, which appears across all these different departments, if you look at orders from a billing perspective, it's very different to orders from a shipping perspective. Shipping is interested in address, the person who made the order. The billing is more interested in the payment details. So separating these in this way reduces the complexity within those parts of the application. And if you go down a microservices kind of architecture, if you're looking at Kubernetes and CI/CD in this way, then the boundaries of your microservices should really align to these kind of responsibilities. So the benefit in working this way is that we can have a team taking responsibility within one of those department boundaries, which is known as a bounded context. So within those bounded contexts, you can have a development team responsible for a collection of microservices. Each of those microservices will have their own path to production, so they'll have their own continuous delivery pipeline. The benefit of working this way is that if you have hundreds of developers, you can scale out your hundreds of developers to work on small areas of responsibility, meaning that they can do loads of lightweight deployments out to production daily without interfering with the rest of the overall team. So if there's a problem with team A deploying their code to production, it doesn't back up the rest of the software department, the delivery department. Everybody just continues on delivering. So if you go down the microservice route, there's a certain number of characteristics that you need to kind of adhere by in order to make this work. So this is based on Amazon's definition of a microservice. Sorry. So microservices are decentralized by nature, so they're not part of a bigger monolithic system. Essentially, they're autonomic, independent subsystems that can operate on their own. They can be polyglots, so they can have different built with different languages or frameworks, have different kind of persistence, single responsibility, they do one thing well, and whoever builds it runs it. So from a support perspective, if you deliver this, you run it and you support it. So there's no longer any of these support teams hanging around, coming in, working on code bases afterwards. That team takes full responsibility 24/7 of it. They're black box and independent. So one of the common kind of pitfalls people fall into is that they'll start working on this lovely microservice architecture hosted on Kubernetes, and then they'll have a big kind of monolithic front end and a big front end team. So any changes that happen on the back end are kind of inherently coupled to the front end. So if you want to release a feature on the back end, you can get that feature implemented pretty quickly, but you're always constrained by the velocity of the front end team. So this is really bad, and it's quite common. So the fix to that then is, again, as we said, that cross-functional team takes full stack responsibility for each of these microservices. So each of these areas of responsibility. So the team will have a componentized front end and a back end and database within their responsibility. So how do we get there? So it's a very difficult thing to do, to take a big monolithic or big business domain and try and break it down into something something that makes sense from an architectural perspective and an organizational perspective. So how do you identify those boundaries, and within those boundaries, how do you figure out, what are the processes, what are the the areas of aggregation that should be should make up my microservices. So one process we use here in Codec quite a lot is called event storming. It's based on something called domain-driven design. So it's an interactive session. We get stakeholders from the product, get them into a room, and we roll a white sheet of paper across a wall. And then using stickies, within about a day to 2 days, we'll map out the entire business process. So it's really, really quick as opposed to traditional business analysis techniques. You can get this done in a couple of days. So what we do is we map out what's called domain events. So domain events are events that happen within your business domain that make sense to everybody. So in that retail example, product added to cart is one. So we put these in past tense because they represent a state change. So something has happened. So product has been added to a cart. The consequence of this is the total is recalculated on your cart. Product can be removed from the cart, will result in the total being recalculated. Next thing that happens in the process is payment is entered, payment is processed, an order complete. So these are the events that happen in the chain from start to finish in getting an order, adding to cart and order complete. So after this is done, we go back and we look at the things that trigger these events. So these are the verbs. So these are called commands, which essentially map one-to-one to your REST APIs if you're using REST API to post, for example. So we have add, remove. We map up the customer or the actor or persona. If you're using if you UX guys there, you can figure out who the type of person that's doing this, and you can extract personas out of this. We look at the aggregates, so the thing that aggregates these things together. So product added to cart, product removed from cart. This is product. Checkout is the action that triggers payment entered, payment processed. Again, the aggregate is order. So in the microservices, when architecting your microservices, then this would fall into products, this would fall into order, and this whole thing would probably come into a context of sales. To create a team called sales is responsible for these two microservices. So this is an incredibly powerful technique. You can get your whole business or your whole team structure out of this and your whole microservice structure out of this incredibly quickly. So this is what it looks like in practice. This is a small company we worked with recently. It took about a day, mapped out their entire fintech operation with a couple of their stakeholders, and used this as a basis then to do a monolith to microservice migration for them. Okay, so in order to get there, as we said before, the idea is to break down functional silos. So back to the value stream map that we've done earlier, we figure out all the different things that's required to get this feature out to production, and we'll take people with those capabilities and we'll put them into one team and align them to that department, that area of responsibility or bounded context. Okay, so that's sorry, I'm running a little bit out of time here, so I'm running through this pretty quickly. So that's the organizational side of things. So we looked at the value stream. We've looked at how you need to modify your organization to actually deliver this in small batches. And the next thing we're going to look at is processes. We're going to touch on some of the good practices that you can use to enable continuous delivery within your teams. So one of the main ones here, you'll notice when we were looking at the slide at the start, we were looking at throughput and stability were the two kind of key tenets of high performance. So what's really important here is building quality in. So back in the back in the Industrial Revolution, they realized that when you're delivering in manufacturing, rather than having retrospective inspection to check for quality in what you're delivering, it's better to do this as you deliver. So in the software development world, this translates to test-driven development. So if you can get your development team to do TDD, it's a really important step to reducing your waste. So this means that the guys will write a unit test for every behavior that they introduce into the production. They write a failing test failing automated test, they'll introduce the behavior, and then from that point on, every time they commit their code, they'll run that test. ATDD is kind of the small step in getting towards full test-driven development, so it's called acceptance test-driven development. This is where, when you define your story that's getting delivered, you write a high-level behavioral test to cover that story end-to-end. So tools like Selenium or UI automated frameworks are really useful for this kind of thing. It's also useful to get that those tests written in business language. So things like behavior-driven development is really useful to kind of get these tests written in a human-readable way. And then automated performance, load, static analysis, and stuff like that. So if you can build automated quality into your delivery capability like this, you'll really reduce your lead times and get high quality software out quickly. So another important aspect is the review process. So a lot of companies do code reviews or PRs. I prefer pair programming and mob programming, again, for the reason that it kind of it stimulates communication between your developers. It stops people working in silos on their own, which is never a good thing. And again, you're not doing retrospective quality assurance. You're finding the issues as you're programming. So you have a second pair of eyes on everything that you're doing, which really improves quality. When you're looking at testing, these are the approaches to testing. So on the left, you can see the anti-pattern here. So this is the ice cream cone anti-pattern, sorry. So you've got loads of manual tests on the top, loads of GUI tests, automated UI tests, less integration tests and less unit tests. So this is a really fragile, really bad way to test your code. On the right-hand side, this is how you should be doing it. Very few manual tests, so these are kind of session tests, session-based testing, just to test that everything's hanging together as it should, and that you're delivering the features to your customer base as it should be. Very few automated GUI tests, lots of unit tests, and less integration tests. Loads of unit tests using TDD because they're fast. Okay, we spoke about ATDD, just out of time here already. And TDD. So I put a couple of links in here. So people have a lot of problems adopting test-driven development, really because of how they approach it. There's a common problem called the fragile test problem. So I've put a couple of links in here just to get people going. If you're doing this in the wrong way, if you start writing tests in the wrong way, it becomes very, very difficult to maintain over time. If you start doing it in the classic way, and make sure that you're testing only behavior and not structure of code, you can put tens of thousands of unit tests into your code base without a problem. Okay, apologies. It looks like I've just run out of time. If I'll go through the questions that have been sent through, and I'll try and respond to these over email. Apology, I didn't have enough time at the end to talk through them. Thank you.
That's great, Owen. Thank you very much, and thanks everybody for going on the webinar with us. I see we had a very good attendance, and we will be emailing you with see if you want us to send on the information on the slides, etc. Okay, thank you very much.
Thank you. Bye.